Hey, we're at JMA Wireless in Liverpool, New York, the factory setting where we build some of the state-of-the-art technology for the wireless industry. I'm here with Scott Walker, who heads our operations in the factory here for our antenna systems division. We're going to take you through some of the assembly line here to give you a feel for how this stuff comes together and how we ensure the best quality happens out there in the marketplace when you're trying to get perfect cell signal on those mobile phones. Scott, thanks for joining me today. And pretty impressive line here. I noticed that you have several, I guess these are work cells, right? And you have several components that come in. Tell me, what comes into here and then how does it flow through this line here?
Okay, so the first components in the antenna is the sheet metal. We make that in-house in our Maryland facility, and it's trucked in. Then we have the circuit boards, the cable, and all the hardware in the main assembly.
So three main components.
Yep, three main components come in, quality checked, come to the line, and what you're looking at right here is one of our three main assembly flow lines.
Okay.
Very flexible model to do the three main operations of antenna assembly. So
we have, with our customers, many different demands, right? So the antenna models and variations change up. Is this the way you have this set up? Is it designed to adapt to that kind of stuff?
Yeah, it's very flexible. So the demands from the customer are changing from the antenna aspect for different beam widths, different tilts, different configurations, 3 to hex quad port antennas in the same package. So what we do is we focus on the core processes that remain the same throughout any antenna configuration.
Excellent.
And that's how this line's set up right
Excellent. Here. Well, and I noticed in each of these, I guess they're called work cells.
Yep, workstations.
In each of them, you have designed a very specific regimen, if I look at it. What I'd love to do is, if we can walk over and you can kind of show us the details. What does that look like and how do you get it organized? Can we take a walk and look?
Absolutely.
Excellent. We're here by one of the work cells, and I like tools. I have a lot of different tools at home, but I don't have one of these suckers. And this guy is hanging from a very neat little trolley here. Why is this assembly in a work cell put this way?
This is for ergonomics, for the comfort of the operator. We do a lot of things, you know, within the station to try and make the operator comfortable. The torque arms for safety are all held on an arm balancer, so you pull it down to the work, and it's on a trolley, so it can span the whole length of the 7-foot workbench.
Nice.
The antennas that we build are 8 foot, so sometimes you're working one end to the next.
And a lot of different nuts that have to be
we have different adapters staged right up here for tooling depending on the size of the nut. This is a low torque controller, so it's controlled right here to a very precise torque measurement as part of quality checks.
So that really comes to our consistency and how things are mounted and bolted on and secured.
Correct.
Now, an operator is at this bench for a long period of time through the day.
8 to 10 hour shifts.
What do you do, so that this kind of work is comfortable for them?
So with that ergonomics in mind, we design the workstations to be very operator friendly. They have a crankshaft that raises or lowers the height of the workbench by up to 12 inches.
Okay.
So taller operators can bring the work up to them.
And I could stand
sit? You could stand or sit. You have the option. They have a chair here if they're sitting. If they want to stand, they pull out the anti-fatigue mat, so you're not standing on the concrete floor all day.
All right.
And very comfortable. A lot of operators within the shift will balance back and forth, sit or stand. If you're sitting, you also have a footrest down there, so we make it very accommodating. The fixtures all slide back and forth, and they actually tilt as well, so you can angle the work to you.
So really designed for good ergonomics for the operator. Organized along the lines of standard, and Kanban is a big element of your production facility here, right?
Yeah, we're a REM, repetitive manufacturing facility, so all of our components are backflush. We don't kit. All the components come out and get in a Kanban grocery store point-of-use storage system.
Excellent. Now, I noticed in this work cell, there's, things are very neatly organized. How does this play into the process and to the standards like ISO that we work against?
Yeah, so we practice lean and 5S principles here. It's kind of our core competency. So our workbench is all set up. All the common components that would go into any reflector build, this is a reflector station, are staged right at the bench.
Okay.
We have standard work. So depending on the finished good model that they're actually building, they may use a percentage or all these components, but it's all point-of-use backflush storage. And it makes it very efficient because a material handler can come through and only replenish these bins once a day.
Very nice.
The custom parts get delivered to the operator on a cart. In addition, we have work instructions for the common process that are written in a check, do, verify format. Yellow, check before you do, green, do, and then red, verify you know you did it correctly. All of our tools are presented in 5S, and this is all on a standard work layout that gets audited every day too to make sure we're keeping up with our standards.
Can we take a walk down? I'd love to see, you know, operators actually doing an assembly, and we can kind of see how
Absolutely.
this all comes together in reality.
Absolutely.
That'd be great. Let's take a walk. We're here at, you know, one of the stations where an operator is actively assembling, and it looks like they're bringing, in this design, 3 different antennas that come together essentially inside of a single antenna package, right?
That's correct. This is one of our hex port designs.
Okay.
So there's 3 antennas within one radome.
Right.
You have 2 high band antennas. This one's going to get installed right to the low band antenna in the middle.
Excellent.
Well, he's working on the top side, which is our radiator stack, which is the actual array and the pattern of the you know, each one of the elements of the antenna.
Now, when I look at the other side of that, and you have an operator over here that is now taking it to the next stage, right? And we can kind of see these cables in their soldered positions,
Correct.
but there's an additional assembly here because the antenna itself has to be connected to the network, right? And you know, I notice here there's a cable assembly that I think is the actual external connector. Is this part of our other connector technology?
Yes, these are our antenna ports that go on. For each antenna has an in and an out antenna port, and they're actually made right in-house up front in our connector division using our compression technology. Each cable actually is barcoded, and we track, tested 100% for PIM and return loss. So we know and certify every connector that goes into our antennas.
Wonderful, wonderful. So this brings everything together in terms of all the internals. You know, I'd love to take some time to go over and see, once all this is packaged, you know, how do we then validate things? You have a pretty interesting area where we do some testing.
All
Can
of
we
our
go take
testing.
a look?
Absolutely.
Excellent,
Yep.
let's do that.
Great.
Well, we got a great view of the assembly process. Now, once those are all brought together, we're here, Scott, with the testing side, and you got several different phases of testing and final assembly. We're here in the first step of the process where the operator has to bring in a final assembly and interconnect to those antenna ports we saw, but how does he know what tests to run, and how does that kind of come together?
So one point to note is all of our antennas are barcoded. So they're all serialized, and the operator will hook up the correct ports, and when he scans the barcode, the test will know what the cal specs are, pull up the program, and automatically run and print out a pass or fail paperwork.
Excellent. So very much kind of automated in that sense for the on the operator's behalf. Allows him to run that test. I notice he's assembling a radome over this during the test. Is that part of the test? It's not part of the final assembly,
So what
right?
we're doing right now is we're testing for visual. Every port gets tested for visual, and then we also test for isolation between the ports.
Excellent.
So as part of that test, here it's passive, but we're under our hanging anechoic chamber, and we put a radome cover on because this is how the antenna goes out to the field to simulate the product for final
consistent in
testing.
its final assembly mode when you do the testing. That's excellent. Now, this is one phase of the testing, and it's kind of a pretty cool environment you have set up here, but you have an even cooler one that we now have set up in the next phase of the testing, which I think is PIM testing. Let's take a walk over and maybe go inside and take a look at that.
Go in our anechoic chamber.
Excellent.
Okay.
Thanks. So here we are in one of our test chambers where we test a very critical element, PIM, or passive intermodulation, which is a critical element to the quality of how well this antenna can deliver a signal. This chamber creates a very, very isolated chamber. What's the makeup of this chamber?
So we've actually built these chambers right on site. It's an anechoic chamber, starts with wood construction. There's no fasteners used, so there's no metal on the inside of the chamber. The walls themselves are sheathed with aluminum, and then they have the 18-inch pyramidal absorber foam all the way around us, including underneath the floating floor. So we actually have no metal. The test table is wood doweled together, and we use plastic test fixtures to hold the antenna.
So obviously metal creates interference.
It can interfere with your PIM test and throw off your reading. So we want to cancel all that out, so we're getting a very good reading on every port within the antenna.
I'm going to guess my cell phone wouldn't work very well inside.
Correct, you won't get any signal inside of here.
Now, when we run the test inside of here, obviously then this antenna is connected up to test gear outside of the chamber, and then this is closed up during that test?
Yep.
Excellent. Well, it's a pretty cool environment when you look at it, and obviously the audio sound is very deadening with the kind of material used inside of here. What's then done after this process? Because this is really a final step in the testing, right? Mm-hmm. And then, of course, final assembly has to take place. Maybe we should take a walk over. I'd love to see the kind of final assembly before this stuff goes out to the tower guys. Well, you've seen us go through the process of testing, through the process of assembly. I'm standing in front of a final unit waiting for what we call some curing. This unit gets packaged into a final box assembly along with results from all the testing that took place, so that, you know, traceability all the way back to the station and the operators is included with each antenna that's delivered out in the field. Now, Scott, over here on this final assembly stage, I see that we have half the radome installed. And how does this assembly come together? I notice you got some special kind of ribbing in here and rivets. Tell us what has to happen here.
Yep, so this one's halfway through the process. It's a 6-foot antenna. So any 6 and 8 foot antennas have multi-piece radomes. Okay. Anywhere we have a multi-piece radome, we put these rib stiffener center supports in, so that the overlap is going to have structural integrity when it's up on a tower. Once the radome goes in, it's actually riveted all the way around, top, bottom, and sides. Okay. Both pieces will go on. We flip it over and we actually run a bead of silicone all the way around the seam to form a barrier.
Well, I can smell the silicone. Yeah. So that creates a nice seal, a weather-tight seal in the entire design then for this antenna that gets packaged. Now, once this is completed and cured, I assume that was the silicone curing on that final unit, we then package it in a certain way to make sure that the delivery right out to that tower site is secure. What do we do that's specific there?
So once the antenna is cured, it's going to go into a box with the bracket kit. So top, bottom bracket kits, middle if it's an 8-foot antenna. We actually use custom corrugated end caps that fit around the end profile of the radome to keep that antenna from shifting or moving within the box, and then a center support bridge to prevent any weight. So sometimes the carriers stack pallets on top of the antennas. We don't want any collapsing or damaging down on the radome. Structural integrity to the antenna.
So very important to ensure that all the way out, and these are very sizable devices that can be precarious to move around, and I can imagine once I'm out there getting them to a tower site in trucks, it can easily be damaged. So we package in a certain way that really protects that. Yep. That's awesome. Well, I want to thank you for joining us today and helping us get a walkthrough of the antenna solution stuff. And for everybody out there, if you get a chance to visit us in Liverpool, come by and see this site firsthand, and Scott will be happy to take you through and showcase this site for yourself. Take care.
Thank you.